Welcome everyone to a new Cypress webinar, Cypress and Ansible. And especially this particular webinar, it's all John's experience at Red Hat, working with Cypress for the last 2 years, and especially rewriting a very large application and rewriting all the tests with Cypress. John, you are a senior automation engineer, right?
Yep, at Ansible, yep.
Excellent. And if people want to contact you, they should go to your GitHub profile, find information there, right?
Yeah, unfortunately, I don't have a Twitter. I missed that window. my tag is gone. Okay, and it's against the TOS default.
It's never too late. So one thing before we start, you can find the slides online. The link is there. It's already public. And as always, we'll answer as many questions as time allows on Slido. We have event code sci-ansible. You can go to sli.do and enter event code. We also will post everything in the chat. So the question and answers will be at the end. We also will have a small poll in the middle of the webinar. So John, why don't you take it away? Tell us about yourself and let's go into it.
Awesome. Well, yeah, so a little bit about me. I'm, as you said, a senior automation engineer at Ansible. I'm out of the Durham office here, and I live here, not too far. So it's been a great experience to. I only have to commute about 3 miles, and in the pandemic, 0. But it's been a great experience. Yeah, so I started UI testing right out of the gate, 2014. It was a different time. It was a dark time. The first thing I had to test was a Adobe Flash plugin, which is no fun. We've come a long way since then. I'm actually going to probably talk about that later at the end of the talk here. But if you need to get a hold of me, there's my GitHub with links to my email and everything, and the website that just reroutes you to my GitHub. So starting off, let me talk to you a little bit about Ansible. So Ansible was bought by Red Hat, and it's been great. And since then, Ansible's kind of grown from what I think many people knew it as, especially if you used us in like 2016. But now it basically allows you to automate just about everything. So you don't even need an SSH interface anymore, or SSH port. But it allows you basically to automate every aspect of your IT department. So everything now. And a lot of people ask me, Ansible has a UI. Well, yeah, we're, like I said, we're best known for the automation language itself that just has the simple CLI interface, super simple, dead simple, straightforward. But actually, we now have, as of today, 3 separate Ansible UIs being tested by Cypress. We have the private automation hub, which is basically think about it as an on-prem Ansible content management platform. It's like Ansible Galaxy on-prem, but way more of a kind of like an enterprise version of that. And then we also have automation analytics, which gives you pretty insightful, a deep view into your use of Ansible across your organization, but also allows you to really drill really far and deep into your into the actual playbooks, modules, and everything that you're using to understand how an individual failure might manifest across the organization. It's really quite powerful. And in order for that information to be available, that all is piped through Ansible Tower. So Ansible Tower, they're going to get mad at me for saying this. It does way more than this. But in the context of what we're doing today, we're talking about managing and controlling the execution of playbooks. It does way more than that. And we have an upstream component called AWX, which is where all the rapid development and bugs happen. And that's what we're going to look at today. So the agenda today, we're going to talk about the UI, the test, and strategies, and the rewrite itself. So today we're going to talk about our journey with Cypress and also the rewrite itself. To do that, we're going to start with a framework comparison. So before we began using Cypress, we did a pretty thorough head-to-head, and it's worth sharing. We also learned a lot about Cypress along the way. We learned a lot about the rewrite along the way, and I really hope that there are developers and product managers on the call here to kind of learn about what our experience. Lastly, we're going to talk about where we're going to go next with the rewrite. And if you have any questions, there is a Slido event, and please remember that code, sci.ansible. So here's this is the best I can do to show you the difference. So this is the rewrite of the Ansible Tower UI. On your left is the old classic UI, and on the right is the new UI, both importantly pointing at exactly the same data set. It's exactly the same. So this is like for like. And you can kind of see kind of how things have moved around, shifted, have become visibly better than the way that they used to be. At the same time, you can see things like the green plus button, which isn't colorblind friendly, being off to the side and now being pushed up in an appropriate place that kind of follows what we kind of know today in 2021 to be the appropriate place for something like that to be rendered. But you can see there's a lot of differences here, but a lot of things are the same. And so kind of keep this in mind when we're talking about this from a testing standpoint. So when we talk about like the page object model and everything like that, things are mostly the same, but the layout is dramatically different. So let's break these down. So the classic UI started in 2014, pre-Red Hat, and it grew organically over time, like everything should. But what that ultimately ended with is a bespoke implementations of certain pages, components, functionality, and ultimately resulted in an inconsistent user experience. And it's just natural. That's just the way good software should be made. It should grow organically over time. And at the beginning, we started with Angular, and now we are on basically the LTS version of Angular 1, which is 1.8. And we had some issues with dependency bumps. So a simple dependency bump, in this classic experience would cause random bugs elsewhere in the app. Always a problem, but we did have tests. And so at Ansible, we automate everything. That means we don't have manual test cases. Everything is automated or done without, manual intervention. And in the old UI, we unfortunately, we did have low unit test coverage, and we had a pretty good exhaustive suite of end-to-end tests that actually did a great job of covering much of the app. But in the time that I used it, Nightwatch.js, which is a Selenium-based framework, it was flaky and slow. No matter what we did, no matter how hard I tried, it was flaky and slow. And with that, we also had, your stereotypical Selenium dependency bump issues where, you have a Firefox version that's out of sync with your WebDriver API, out of sync with your Chrome. Everything changes unnecessarily. We needed to refactor it to support some of the great things that come with ES6, which, obviously when we started, we didn't have it. And generally speaking, in order to understand the results, you needed QA interpretation. You needed to find a QA medium and sit down with them and help you understand what failed and why. So why rewrite? Well, there's three main reasons that we did a rewrite from a development standpoint. Pattern fly. So post acquisition, we needed to standardize with the rest of Red Hat. So actually what you're looking at the right is not Ansible Tower, but automation analytics, and it looks and feels almost the same. I think it could be almost mistaken for the same. And that's because we harness the power of Pattern fly. Pattern fly is an open source design library that's used across all of Red Hat UI. It makes a really consistent and great experience and brings a lot with it. The other thing, Angular 1.x depreciates this year. So if anyone's on the line right now and is still running that, just realize that Angular 1.0 is going away this year. And it didn't meet any accessibility standards. Came out of 2014, wasn't as big of a deal. We looked at adding it back in and ultimately said, you know what, let's go with doing it the right way with a new UI. So with that new UI, this is an enterprise product. It has a lot of functionality. And so the main thing that kind of drove it from my perspective is feature parity. It needed to do exactly the same thing in the new UI that existed in the old UI. I think everyone on the call has been a part of or seen or used a UI that's better, but missing the thing you need to do. And it drives people up the wall. So for us, feature parity was key. And that's what we've delivered. With and the other thing at the same time is we looked at the different, front end frameworks out there. We had Vue, we looked at Angular. I think they're on 11 or 10 or 5. I don't even know how that modeling works anymore. And then React. And ultimately, we went with React because of the Patternfly design library that we were using. They provide native React bindings for everything that they do, which is fantastic. So that's why Automation Analytics looks identical to Tower in many of the components. And so what you see there is a consistent user experience, not, I guess I should say, across all of Red Hat, but also within Ansible Tower. No longer did we have these bespoke implementations or these rough edges. Everything felt and looked great, and it was the same. And Patternfly came with accessibility in mind built in. Fantastic, for free, effectively. But in terms of the tests, you have to say, what would we have done differently in hindsight? So think back, when you get back from this meeting, go look at your test code base and think to yourself, what could I do if I had all of these years of hindsight to make it better? And that's really how we kind of approached the new tests. We made sure that everything was automatable, but not necessarily going to be automated. And we'll talk about that in a little bit. We had high unit test coverage as a goal. Visual regression testing is a must. It needed to be fast and reliable. And we wanted to do a lot of the test architecture up front. Now that because we knew what feature parity meant, we knew what the goal was, which you can't get in most other, parts of your life. You knew what it was going to look like in the end because you knew what you had. And it was fantastic to have that. So we could kind of design everything with milestones and everything. And then lastly, importantly, we wanted it to be self-service. So no more QA interpretation. Devs can use it for themselves. So in terms of the rewrite strategy, we had a few options, but ultimately went with starting from scratch. There was no migration. There was no hybrid approach. It was old UI or classic UI, new UI. That's it. Nothing in between. This simplified a lot. And because they were so divergent, it actually was the correct choice. The other thing that we did was instead of building by Pendo, which we mean by we knew because we use Pendo, and if you haven't seen it yet, I would go back last week and watch the Pendo presentation. We know exactly where our users are in the application with all the analytics that we have. So instead of building towards usage, we actually built by dependency so that we could get to that point. So we know that most people are in the job results page, but in order to get there, you need to have a credential, you need to have an inventory, you need to have a project before all of those things. And then you need to have an organization at the beginning. So that's where we started, an organization. UX improvements. We had feature parity, but we were going to do it, 2021, we're going to do it better. And that's ultimately what we delivered. Also, we had the opportunity to make some API changes to actually improve the UI. So in the same way that the UI grew organically, the API grew with it to match that. And in some cases, we were making 3 or 4 calls to do exactly the same thing that we were able to reduce down to 1, which was great, improved performance. The last thing I wanted to talk about is partial implementations. So the rewrite strategy is, this is the view that you looked at, but we didn't, for example, implement the add button and the delete button at the same time. The search button, the search bar, and the dropdown may or may not have been there and may or may not have been functional. The individual columns that you see may or may not have been there. Now, if you think about that, that's naturally how you would build things, start small and branch out. But again, this is a 100% feature parity rewrite. So everything had to be there in the end. So that kind of drove our test strategy.
Gotcha.
So for us, there was so much changing in the look and feel of the UI. We also took it as an opportunity to start from scratch. So we effectively deleted the old code base, which I don't think
all the tests.
Exactly. Delete all the tests.
Good advice, right? Live dangerously.
Exactly. So we, at the same time, we wanted to implement tests and test functionality alongside with the dev. So the ability, for example, to upload a file to the UI, we actually figured that out just a little bit before the devs got to that part of the app and did a POC with with Cypress and figured that out. But we also modeled our test development with application development. If you looked at the partial implementation slide before, we actually wanted to use the test code base as a source of truth of what was implemented and what was not. And that made sure that we always knew how we were growing, kind of fleshing things out. And we did that with to-dos, which we'll talk about later. We got to maintain the API tests. So, it's a rewrite only in the UI. So we got a lot of confidence that, the API was still functioning through we had thousands of tests there. We wanted to balance the unit and end-to-end test coverage, not necessarily lean too far in one direction. In terms of the strategy, Patternfly was an unknown. It was a risk area. It was a source of destabilization, or so we thought. I'll save it to the end with what we found. But the other thing that kind of drove us was, how do we build things without deleting? How are we? We're not lean, because lean, to be lean, they want you to delete things. We wanted to be, we didn't want to waste time. So we built small and created like a solid foundation. So here was our testing wish list after 2 years with Nightwatch. We wanted a total runtime of 30 minutes. So what that meant was, when we got to 30 minutes, figure out parallelization and then figure out how to keep it. So we never went beyond 30 minutes. Keep a 5-minute test suite runtime. This is a very particular thing for us, because we wanted to move all of our testing to the Google Kubernetes engine. And the Google Kubernetes engine has this idea of a preemptive node that says, when you, if you can execute all of your work on a Kubernetes pod in under 5 minutes or under 10 minutes, you only have to pay 20% of the cost. So it was a way for us to build an architecture in such a way that we could be as cheap as possible and run with a lot of vertical scaling. And that was really important to us. In terms of, we wanted to make it stable and testable being like the ability to actually grab the thing from the DOM without, sifting through all the cruft around it. We wanted a good locator. And the last thing to talk about is pre-merge testing. So this was really important to us. This is from a study about the cost of a software bug in the lifecycle. Because this was a rewrite, everyone knew what the requirements were, or the gathering requirement. We knew what that was, but we also needed the ability to, reduce the number of bad merges into the develop branch that could have easily just been caught by just running the test beforehand. And that kind of like really helped us kind of drive what we did. And we'll talk about that in a little bit, where we ended up with that. So before I go forward, I do want to talk about, doing a test framework comparison. So there is an active poll on slido.com. So feel free to answer.
So John, you want us to ask this question: how long does it take to pick a new test framework, right? You have to evaluate all your choices before you can pick. How long does this process take? Just luck of a draw. Throw a dice, pick a framework, you're done in 1 minute. That's it. Right? But probably it takes longer.
Yeah, and I think it depends on if you're a developer or if you're in QA. From a lot of the times, what I've seen when people pick a new framework on the QA side is they want to stick with what they know. Like, they want to stick in Python or Ruby, and they're afraid of JavaScript in some cases. And so that really limits you to what you can do to Selenium, I think, a lot of times. And on the other side, I think a lot of developers will find a good guide and just run with it and, get it working in a weekend sort of thing. So curious to see how this plays out.
So John, while people are still kind of answering the poll question, let me just kind of clarify what you had. Were the developers writing tests as they were doing the rewrite, or was there a separate QA team adding all the tests that you deleted? How did it work?
Yeah, so that's an interesting question. So we wanted to make a clear separation of concerns. So the developers were basically responsible for the unit tests, and they were going full bore, lots of coverage, everything was great. And keeping things basically up to the point of testability, making sure that the end-to-end test, the Cypress test, could actually, locate the different elements on the page. But it was the responsibility of the testers at first to get to the point where we we would write everything. It is in JavaScript. They were welcome to and often did contribute. But at the end of the day, we wanted to keep the pipes flowing, keep things green, and keep the coverage kind of figured out.
I see. Okay, so a lot of people answered the question, the poll question. It seems like great majority takes from a couple days up to a month to pick a framework, right? So, John, what does it tell you?
It tells you that you did what we did. So, yeah. No, this is great. Do you mind if I hop into the next slide?
Go ahead. Yes, I think it's
awesome. Yeah, so let's talk about what we did. So for our test framework shootout, we had Nightwatch.js, which is Selenium based. We had Cypress and we had Puppeteer, and we used the Jest bindings. And what we ended up doing was doing a head-to-head here between effectively Selenium, Puppeteer, and Cypress, which at the time were the big three, I'd say. And so we did 2 weeks. So we effectively set aside 2 weeks of engineering time with 3 engineers to do a comparison between these three with some pretty, thoughtful rigor here. We had the gentleman that had the least amount of experience with Nightwatch actually writing Nightwatch tests, so it was a fair fight. We had Cypress given to one that had never seen it before, and I took it as an opportunity to learn Jest and Puppeteer at the same time. So totally equal, and we all knew at the end of it that one of us would win and the other two would be thrown away. But we never thought about kind of like the sunk cost of bringing the old framework with us. Mm-hmm. So in order to do this, we picked 4 test cases on the CRUD, create, read, update, and delete on an organization, and said, get there. So we said, it's going to look like these 4 tests. And then we would do a head-to-head at the end. And in between, we documented what we found along the way without asking each other for help, so that we could see what it's like to be isolated, to see what it's like to kind of work with a framework, and see what the community has done with it. And this is what we came up with. So we had, I think a 4-page report, and this is taken from that with a little bit of hindsight. I think these are more like a highlight reel sort of criteria and requirements. And this is all accurate as of May 2019 when we did this comparison. So just keep that in mind. This is not necessarily the case today. So starting from the top, we have Nightwatch, which is what we had before, but this is doing it, with ES6 and doing it with the latest version. We had Just Puppeteer, which is Puppeteer and Jest combined together. And then we had Cypress. So looking at the rows, we had multi-browser, and this is the big one. So Nightwatch.js is Selenium based, so it supports everything. I think that's what everyone thinks of when they think Selenium. They think of multi-browser, multi-operating system, run everywhere. Just Puppeteer, on the other hand, no. Just Puppeteer was using Puppeteer, which is it only uses Chrome, is what the Google team uses to test Chrome itself. And then we had Cypress, which at the time was Chrome only. There was whispers in the wind of other browsers coming, but at the time it was a no. We also had an open source software bus factor, which for those of you that may not be familiar, there's an idea of, if the contributors of this framework or a tool or plugin were hit by a bus, what is the likelihood that it would continue on? So a low rating is a bad one. A high rating one is a good one. There's people to take on the mantle if anything were to go wrong. For Nightwatch, that meant there was basically one person or maybe 2 people leading it. So it was pretty low. We hadn't seen any problems in our use of it, but it was a risk factor there. Just Puppeteer, there's actually quite an exhaustive community for Jest, a huge community for Puppeteer, but the combination of the two, it was actually quite small. I think less than 3 people. And then Cypress, on the other hand, has quite a large number of contributors to the core, but they're mostly, just like Ansible, coming from the driver there. We put an asterisk here because there's a very active and very a thriving plugin ecosystem that allows people to add functionality. And I think, Gleb, I would say it's true that you actually take some of those plugins and you bring them in to the core. Is that right?
Yes. So some of my plugins that I maintain in free time are now part of the core, like the component testing. we're thinking about some others, one like a Cucumber, we're discussing with Cucumber maintainer to bring it in, but it's still work in progress.
Awesome. And we have visual testing was huge for us. So we had Nightwatch, yes, across the board. They all supported it. Triage ability, which is, I mean, if you think about it as QA, what you usually do is you come in the morning, drink a coffee, and read the nightly failure reports. So what we really wanted to do is kind of lower the burden and honestly make this easier for the developers to do as well. So with Nightwatch, we actually had a lot of infrastructure already built for this with video recording and screenshots via and dashboard functionality via Selenium. And that was kind of sunk cost for us. Most people, if building it from scratch, wouldn't have had that. So this was for us. Just Puppeteer, nothing. It's literally just read a command line error, and if you implement it yourself, a screenshot. And what Cypress had was everything. It's video, it's dashboard, it's timeline view of what was being executed and what you actually saw with DOM snapshots in between. It was impossible not to know what went wrong. And it was, that's really important because of the next one, which is we wanted to mock out the network. We sell the API as much as we sell the UI for Ansible Tower. And so a lot of what we do is interacting with a versioned, interface. So we wanted to be able to mock some of that stuff out. Nightwatch, nothing. Just Puppeteer, yes, but we never got it working even after 2 weeks, to the extent that it needed to. Cypress, it was, just grab the example and go. And the reason that I brought up triage ability to that is what we ended up seeing through that network mock, exploration is when you're automating UI tests in Cypress, you see all of the network requests in the background in line. It makes it really easy to know when an API request failed. So parallelization, yes, no, yes. The only asterisk on Cypress was you need a dashboard, which has a lot of extra benefits that we're going to talk about in a little bit. Documentation, Nightwatch is actually pretty good. So we knew what it was. It was a known thing. So it was a medium. Just Puppeteer had nothing. It was basically owned, you could look at the Jest documentation, the Puppeteer documentation, but you were kind of on your own on the combination of the two. And documentation for Cypress is off the charts. It was really fantastic. The last thing that we needed, which we mentioned, was the to-do functionality. Nightwatch, no. Jest, yes. This is a native API for Jest. It's fantastic. It allows you to say, I'll come back to it without just skipping. And then Cypress was no. That was...
You'll show what it is, right? Later, you'll have an example.
Exactly, yeah. So this was holistically all the requirements that matter now in 2021, but this was our comparison. So you can guess who won. Otherwise, I wouldn't be here. Yeah, so we basically, this is what I wanted to call it was the 3 differentiating factors. It was multi-browser and it was documentation. So documentation is really what drove the, tipped the balances in Cypress's favor. There's nothing really wrong with Puppeteer in that way, but the combination of the two was kind of unproven. And in our case, at the time, there was no Firefox support. So, and why this is important to Red Hat and why this is important to us is one of the Ansible Tower's biggest users is the United States Postal Service. And they have a subscription to RHEL, Enterprise Linux. And as part of that, we actually include a bundled version, a tested by QE version of Firefox. And so, it's really important as us, as the Red Hat citizens to support something that we sell, which is a enterprise version of Firefox or package. We don't necessarily drive it. So that was why it was so important. But ultimately, I lost some sleep over it, but we went with Chrome only. So what did we learn? Well, what we learned was, everything seemed to be a solved problem. We wasted almost no time on experimentation and ultimate failure. We've deleted very little. I think the only thing that stands out to me that we deleted was we used a bunch of different browsers and applet tools and we ended up not wanting them because of the runtime that it added. So we just reduced the matrix down to like 4 or 5. And that's a product of two different things. The API documentation is great, and inside of that documentation there are working examples. And even then, if you can't figure it out, there's working examples for everything. So we did Percy and Applitools for the visual stuff. It was really great. There's also a plugin ecosystem for anything that's not in the core, which we talked about. So accessibility testing was one thing that we wanted, and it just came from the ecosystem. Very little in terms of experimentation. But the best example we have of the documentation is how it impacted our runtime and really how it impacted our architecture. So when running and building, deploying, all that kind of stuff for Ansible Tower in Jenkins, it takes 22 minutes to do that. So it takes 22 minutes to do that. That means that if you had a single test, it would take 1 minute or 23 minutes. If a single test took 1 minute, it would take 23 minutes to get a result. So even with perfect parallelization, that's the best you got. But if you run everything in serial in Jenkins or anywhere, our runtime at the time was around 3 hours. So, if you wanted to build and deploy, it'd be 22 minutes plus 3 hours. But what we looked at was kind of taking our internal build for AWX, the upstream, and we were able to use GitHub Actions and the caching mechanisms and everything to get it down to 5 minutes. And cleverly, I won't say it's too clever, we just copied the Cypress GitHub action, the official one that Gleb, I think, Gleb, is that what you maintain?
Yes.
Yeah. And we just grabbed and go, and we also use caching and everything in it, and just combined the two in parallel. And what that meant is we could build and deploy the application in Cypress alongside one another in 5 minutes because of the principles of scaling there. And then the powerful thing that Cypress provided was the dashboard with parallelization and test load balancing built in. So at that time, we were able to simply choose how fast did we want it to go.
Yeah.
And that's what really was fantastic. And here you can see our real data with the real, it's even got a link to the GitHub Actions report for improving things that goes straight to example repo and everything. You can see where we chose. We decided on 17, we divide everything up 17 ways. And it was responsibility of the Cypress to kind of say, well, this machine came online, all 17 machines came online, you get this test, you get this test, you get this test. Oh, you've stalled on this test, well, then the other ones load balance and get these. And it does that because it has a complete history of how long the tests take, which is fantastic. And you can see here, if we wanted to go faster, we could get it down, even faster by going 24 ways.
Nice.
So what that means is, because we wrote all the tests to be complete in 5 minutes for Google Kubernetes Engine, what we ended up with was all these test suites that pretty neatly and compactly fit into this time of 5 + 5. And we optimized on 14 minutes. So to get feedback on all of our test suites, and more importantly, regardless of how many more we add, we could add 3,000 more tests and we would still get the feedback in 14 minutes, which is fantastic. And as a comparison, our unit tests when running in Zool actually takes 17 minutes. So from a developer standpoint, they get faster feedback from the end-to-end tests than they do from the unit tests, which is insane. And that's really because we just kind of grabbed components from documentation and things like that. So the other thing we learned is that you can leverage Python from within Cypress. So there is this, the ability to execute arbitrary commands with sci.exec. So in our case, we decided to reuse our existing Python-based SDK. And you can see here the command line to do that, where we effectively have Python, the Python file, which wraps everything that needs to run it, the command, and then the URL from the Cypress config. So what effectively is happening is we install the Python, we install Python and the Python dependency on the file system, and then tell Cypress, hey, run this command called, in our case, it was create or replace on line number 2. And what that would do is it would execute line number 4 and give you back, this is the important part, a JSON object of the standard out. So what this meant is in the test code, what we could do is simply execute line number 2 here, run the Python and return this object called cred, and then use that in your test. So in our case, we were able to use that object in our test with this.cred.name, which is a part of the returned object, the ID, and verify that if you look at line number 8, the API response between the browser and Cypress to the API.
Nice.
So the object was created in the back end and then referenced in the front end directly. And what this, and so I'm going to elaborate on this example. The big thing that, I actually did lose sleep on this, Gleb. You have this, this blog post about not using the page object model, and it's all I've ever known. And it was scary. But I decided to kind of go with it. And it turned out not to be a problem, as long as I think you're not a true single page application.
Probably.
So in our case, if you look at this, we take line number 2, and then we directly navigate to credentials, then the search query, this.cred.name. So what this in fact does, if you think about the page object model, what this would normally look like is you go to the login page, you click the login button, you go to the nav bar, you click the nav bar, then you go and you're routed to the list, then you type in and you search for something, then you wait for the return value. We've skipped all of those steps and we go directly to the object as it's referenced by the URL query structure. So our tests are running, it's unapologetically fast. It can't get faster than this. And honestly, what we found is effectively that we're running effectively as fast as we can with some of these assumptions. And what we, and the other half of this is, how do you know what you're doing? What we've asked for from the developer team who has, helped us along the way is unique elements that make sense. So in this case, it's an ID that describes exactly where you are and what you're doing. It's the credential list copy button. And when you click on that, you can wait for these API calls to come back from the API and end up in the browser before moving on and asserting that you've copied the object. So just to show that again, the page object model is really you don't need it in our context for 2 reasons. If you know what you're doing with a good ID locator structure, you know what this test is doing, clicking on the object, and you know where you are. So that's how we got away from it. And this test couldn't be faster. It's been great. What did we learn about the overall strategy? Well, we didn't really find any multi-browser bugs. So we labored and we honestly wasted a lot of time worrying about the lack of Chrome because the bugs themselves haven't come. And I think that's actually less to do with the Cypress, but the quality of the dev team. And honestly, I think in 2021, honestly, with modern React tooling and everything, it's less of an issue. And there were no pattern fly design library bugs. So we had this as a massive source of risk and they just never came. And it's possibly because they are actually using Cypress themselves and they do quite an exhaustive amount of testing upstream before we get it. And it also could just be because, generally we don't have bugs because the unit test coverage is so great. But this was really fascinating. So in the end, I think where we're at now is the community that now that we've released to this community has found 26 bugs out of the hundreds that we found internally during the testing process. And so they're just not escaping. In terms of the test rewrite strategy, it wasn't a good idea to delete the test. So we took all of the old test definition and rolled it into Cypress when we started. So because we knew about those, they didn't work, they were stubbed. But it turns out what we ended up doing from a platform decision is we added an interstitial release between the old UI or the classic UI and the new one. And then we put that one and pinned it as a LTS release, a long-term service. So it's going to be around for longer. So we wish we would have kept them. So we're actually re-adding them now, turning them back on as you were. We avoided test or we did test deduplication. We only tested one thing if we were on a certain page, and we'd make longer tests. And that has really benefited both in runtime. And you can only get away with that if you have the kind of like the triage ability of Cypress, the ability to see exactly where it failed. You can get away with longer tests. And if we could do it all again, we'd start with data ID test attributes. We started with unique IDs, and now we're adding data IDs back. But the main thing we found, it was actually very difficult to keep up with the devs. They kept flying past us. And so this is where I'm going to bring up to-dos in our strategy. What we ended up with was the definition of done before something moved in to got merged in is we needed testability. That was kind of the floor. It wasn't, 10% automated, 10 or 40% automated or anything like that. We just wanted to make sure that when we come back to it, when we come back to add coverage, that we don't have to destabilize it by adding in testability. So when the developers added something, you saw it was like credential list copy, the ID. We wanted this, which is the thing that we could, the attribute we could come back to later. And then what we ended up with is this, over time, the test code base became the source of truth via stubs of what was implemented and not. So in this case, this is a stub test that is just skipped. It doesn't have any functionality, but if we had more time, the QA team would have added that test. Mm-hmm. And the last thing is we maintained a version of what was in and out with a TBI stub, which is a dot skip with a link to the feature where it will be when it comes in. And what that meant is when that feature did come, we would grep the code base for all the tests, run them all manually, automate the ones we could, and then kind of move on. And I'll show you why that is a big deal. We have a lot of functionality. Like I said, nothing was documented. We had no idea that when implementing just BDD style test cases, we'd have 3,100 test cases. It was unknown at the time. And many of us were kind of new to the code base and all that kind of stuff. So we only had effectively a little over 2 engineers for most of the project. It was impossible to add 3,100 tests in effectively 2 years. So Gleb, I guess we should talk about where we're going, or did you want to talk about any of the previous points?
No, I just want to point out that that chart that you're showing with number of a test, that's what Cypress Dashboard Analytics tells you. Like you can see how long the test take to run, the size of a test, where you're going pretty much, with flaky test, all the jazz.
And you can also see one more thing, Gleb. You can see when the Christmas vacation started and ended. I don't know if you can
yes, nobody was running. So
yeah, nobody was
running tests. So if you want to, let's say, find bugs in Ansible Tower, just look during Christmas break.
Exactly.
Nobody's running any tests. Nice.
So let's talk about where we're going. So let's talk coverage. I think is the great place to start. So we have a pretty solid foundation. We know, everything that should exist today. We have stubs for it. We have real working tests for it. We have, I think, like 500, 600 tests out of those 3,100 that are automated. And again, I did say that we did longer tests. So often, and we don't know how to measure this, Gleb, maybe you can help us, but we often have one long test that contains several others inside of it. So that was kind of our strategy. So this 3,100 will never totally be automated. We'll have coverage for them in other ways. And if you recall, I said we didn't go with Pendo for the implementation. So what our test coverage actually kind of follows the dependency order of how users need to create things in the application. So there's an inverse relationship today with what we know to be where users are and what we have tests for. And that's what once we're totally done with feature parity, that's the first thing we're gonna do is make sure we cover everything. The next thing is something that's really cool, I'm really proud of, and we got it working again, it's a solved problem very quickly with documentation and examples. And also, if you haven't seen it, there was a codecov.io presentation with Cypress, where we actually were on the call like you are today, asking him questions about it and followed up with him afterwards about implementation. And so what you're seeing right here is actually the total of all of our coverage. We've actually combined our unit test coverage and our end-to-end code coverage into one report. And you can see, oh, my mouse died. Oh, there it goes. Okay. You can see we're at around 88.43% line coverage. And you can see I've highlighted over the area down here, which shows you where we need to add it. So this is like a sunburst chart that allows you to drill down and see where you need to add coverage. And the area we need the most is on the workflow job template visualizer modal. Once we add that, either at the unit test level or the end-to-end Cypress level, then we consider that covered.
Nice.
The last thing, or there's two more things. One is speed. We've spent no time optimizing our runs, but thanks to the dashboard, it tells you the longest running test. So you can see here, once we get there, we can just start chopping one by one. And we can do it two ways. We can either split the test, a longer test, into multiple tests to allow the parallelization model to take hold, or we could just analyze it, see are we doing anything, any missed test or any test duplication, we can remove it, or anything like that. We have this at our fingertips, we just haven't got there yet.
That's interesting.
The last thing I wanted to say is we have followed this principle of testing the UI and not through it. Like we, as you saw, we very clearly jump in and jump out of Cypress. And the best way of seeing that is actually on the Cypress dashboard, they show you your execution time. In our case, if you look at this test, 15 seconds of it is in the before each in red.
Yeah.
And so think about that. Think about if it takes you 15 seconds to do it natively against the API in the using the SDK we have. Think about how long that would take to build in the in the Cypress test. It would be huge. So that's why we've leveraged it. However, I think there's a lot of lost implementation here. Or optimization here. And in the end, if you look at this test, only 5 seconds of it is actually in the UI within Cypress. So between 6 and 12, only 5 seconds have gone by in the 23-second test. So I think, honestly, instead of optimizing on the Cypress side, I think there's a lot left on the table here to optimize on the SDK side. And that would also make the potentially the API test faster.
Very interesting thought.
And talking about going forward, more coverage. So on the left is the Applitools screen or the view of the Japanese version of Tower. So I've included a code example here on the right, which is a way of loading in all the different languages. So we can load in Japanese, French, Spanish, Dutch, simplified Chinese, and even a pseudo localized language that we've bound to Zulu. Hopefully no one speaking Zulu is trying to reach this app, because you'll see pseudo localization. But what we've done is we've parameterized all of our tests. So we kind of loop through them. And so we can test the UI in all the different languages. And if anyone on the line, if you can see it, there's one missing, there's a bug here. I don't know if everyone can see it. There's one missed piece of text that needed to be translated into Japanese that wasn't. Type it out into chat if you see it. Let's see, does anyone got it? Job, yeah, it's job runs, yeah. Yeah, so admin's the user, and we do test that. We do test that you can enter in non-English characters, but yeah, it is job runs, wasn't caught to be translated. Yeah, exactly. Exactly, Pete. But yeah, so I guess the last thing I wanted to say, didn't have a way to show this yet because it's actively in development, but in the same way that that we had the entire rewrite affect QE, we also had it affect the docs team. So because we're able to use the screenshot functionality, what we've done is we've taken all these visual tests and we've made a point to create a screenshot of where it would exist in the documentation for the doc team, with the file name that matches in the file structure that kind of follows what the doc site is going to look like. So we can help that team kind of keep up.
Right.
Didn't have anything to show for it, but in summary, so today we talked about the rewrite, our migration, what that meant for the UI and the tests. We talked about the test framework comparison and what it meant to us at the time. Remember, May 2019. We talked about what we learned about Cypress and what we learned from the rewrite itself. And I'm really excited to talk about where we're going next.
So before we go to the next, right, which is really our last slide, we do have a lot of questions, right, from the audience. John, do you mind going to the next slide?
Sure.
Is there any question that kind of jumps at you, or should we just go in order?
Which strategies do you use? Order is fine. Which strategies do you use to for commands or components? So we just follow the rule of three. Anytime we're using the same command in a test suite, we modularize it into a command within or a function within the test suite. And then if it spans at least one test suite, we move it into a command that's shared across the application. One of my coworkers, Tiago, is really interested in component level in working with components. So I think he's going to drive it that way as well. But yeah, we've done rule of three, moving it to a common function, then to a shared function across the app. Since you've mocked the API, since you've mocked the API, how do you keep up with changes to the API? We're lucky. And so there's a lot of context to this project that you may or may not have. And I didn't really illuminate all of them. One of them is we sell the API. It is a versioned API that a lot of people depend on. So we can make a lot of assumptions about the rate of change. So that impacts our strategy. I didn't have a chance to show it, but the other APIs that we've mocked, and you'll find this interesting. We have a lot of integrations with Tower. One of them is like a third-party credential store, like CyberArk. Maybe some of you have heard of it. What we've been able to do in our tests, and I wish I had put it on the slide deck, is, and maybe I'll find a way of sharing it, but we actually mock out the integration with the third-party service from the perspective of our UI test suite. And to your question, we don't have a way to keep up with the changes of that external API, but the cost of setting that infrastructure up and maintaining that over time would blow past the 15 minutes, 3 hour mark of our testing.
I see. John, there's a question about visual regression testing, and I know you skipped a couple of slides. Do you mind maybe, because we have a couple of minutes,
yeah,
do you mind going back to column 14 to the bottom, because you do have those slides. So yep, and go down. If you can go down here. Yep.
Oh, I think oh my gosh, I skipped a section here. Actually, yeah, so let me just talk about this. Thank you. We talked about the fixture, we talked about that. But yeah, so we do all of this through Applitools. We did that with Cypress as well. Gleb, did I skip over this section?
You did skip.
Okay. Yeah, so let me talk about this just really quick. So we have the fixture data for time series plots, and it allows us effectively to stub out our API interaction to the dashboard API. And so you can see here that this is testing 921, or sorry, with the big enemy to visual tests is time, especially when you have things like time series. So what we've done is we've mocked out the API response from the back end, and we've included it here so that every time we visit this page, it's represented in the same way. So for all of you that have used visual tests, this is always going to appear the same. And the only bugs that kind of shake out is when it renders incorrectly. The second part of this is you can only do this in Cypress, from what I found, is modify the API response on the wire with sci-intercept. So if you have timestamps in your app, instead of ignoring them, you can actually just intercept them on the wire. So ever since November 9th at 6:22 p.m. when we got this working, all of our timestamps have been the same in our visual tests. So we can control for that. So you never have to worry about diffing on those. I guess I should also say that visual tests find a whole bunch of bugs. That's another thing we learned. So I don't know if you can see it here, but on the right-hand side, there's the dev tools firing hundreds of requests. We're effectively load testing the API. And the reason is there was some state mismanagement or problems here that only the visual test found, because functionally everything looks right, but happening very quickly. And you can't even see it here, I don't think, but this credential button is actually disabled, enabled, as it's waiting for the the API response to come back. So visual tests ended up finding bugs in their own right that were almost impossible to find functionally. So let me, if you don't mind, Gleb, I can talk about the next slide here.
Yes, yeah, go ahead.
Yeah, the other thing is the dashboard really does break down the barriers between dev and QE. So in here, this is actually a comment on a PR from a developer. They look good to me, but they're still failing. And the way that they're able to tell that is because of this little juncture here. This is saying on their branch, on their PR, there is a failing test. However, they can see quite clearly that it's also failing on the develop branch. So self-service, what we've been able to do is keep it kind of self-service. So at the same time, I'm glad I'm just going to finish this last slide if that's okay. The tests have been kind of self-service in some ways. UI, for those of you that are doing UI testing, you're usually the bearer of bad news. So any number of things could break and you have to report on it. So Cypress makes it easier. What we do is we run all of the tests every 3 hours to establish a baseline of functionality. And you can see quite clearly here on this run, this broke, and you can see here the commit that broke it and a link to it. So this reduces the triage time. It's been fantastic. So we made these tests more or less self-service. And then the last slide here that I skipped. Sorry, guys. The last slide here is embracing failure. One of the things we learned is to kind of embrace failure and to say flaky tests are okay as long as you know about them. And that's what the Cypress Dashboard and flakiness rating helps you do. We haven't always been green, but at least we know about it and why. So the developers know that as well.
Excellent, excellent, John. So no problems. We got to our slides, so nothing was lost.
Eventually, one way or another.
Do you mind going back to the very last slide? Because we're out of time, we will answer all the questions that you submitted offline, right? So everyone who wrote a question will get an answer from John and myself. Do you mind going to the next slide? Because we're out of time.
Yeah.
I want to thank John, first of all, because you did such an amazing job, right? Approaching us, telling your story, putting the slides together, and doing an incredible job presenting the slides. Thank you, John, so much. We really appreciate it. And also thank you to the users of Cypress who joined this webinar to find out about Ansible. You can find slides online. We'll send the recording soon. Happy testing from me and John. Any parting words of wisdom?
No, I'll answer any of the questions you throw at me. So yeah, I'll follow up with the Slido deck.
Everyone, take care. Have a great day.
Thanks.